Hi guys, today is day 18 and from today onward I am planning to start the concept building. Until now I discussed mostly the tips and tricks, what kind of tips you will follow during the system design interview. Why it is important? Because most of the time people are prepared but due to a small mistakes they are not able to clear. So for those kind of audience, the 17 tips I have shared, please go visit the all videos and try to understand the underlying tips given in these videos. Alright, so from today onward, I will share you basically what are the construct you should be aware for preparation of system design interview better way, right? Because system design is all about your knowledge and utilizing your existing knowledge for the given new requirement. Please understand that system design is not a very different thing. Like you have to select set of tools, set of concept only, but adopt those concepts in your requirement. That's it. So there are 20 to 30 maximum concept. If you remember, if you know very well, then there is a very less chance that you will stuck in system design interview discussion. The success and failure, it depends on how you have performed on that day, but at least you are equipped with the armor, or I would say that you equipped with the skills which is required to start performing in your system design interview. And the first topic for today I picked event driven architecture. And this is the core pillar of distributed system where we purposely designed our system where most of the system are loosely coupled. Most of the components are dependent to each other but very loosely fashioned. They are not directly or strongly dependent to each other. Alright. So as the name suggests, this is called event driven architecture. What does it mean? So before going to definition, let me give you that event driven architecture are highly beneficial for building a scalable, flexible and responsive system, right? Especially in modern cloud environment, event driven architecture can help you react efficiently to state changes and user actions. Let's understand what is event driven architecture. So an event driven architecture is a model where components of a system communicate through events, either in real time or asynchronously. Events trigger communication, enabling decoupled services to interact and respond to changes. Alright. Next thing is, let's understand the core component used inside event driven architecture. Primarily, we consider three core components inside event driven architecture. The first component is called event producer, another is called event consumer, and the third is called event broker. So producer, consumer and broker. All right. Let's briefly give you the definition of event producer. System or services that generate events such as user actions, maybe click, or maybe something submission, form submission as an example, or anything which is changing the states, data update, right? Like somebody has update your data, and on the basis of data you have to do something, maybe view for view purpose or for anything other purpose, right? So that kind of things is comes under event conditions. Second thing is event consumers, services that listen or listen to and act upon events is called event consumer or listeners. These can trigger process based on the received event. Alright? An event broker is the tools like Kafka, RabbitMQ or AWS SNS SQS that manage event distribution between the producer and consumer. They ensure efficient routing and delivery of events between producer and consumer. Alright? So that's why it's a very important component, event broker. And one example of event broking is Kafka. Another may be RabbitMQ. From AWS side, it is SNS or SQS. Okay. All right. Let's move to the some key advantage of event-driven architecture. I think in introduction I already mentioned scalability, decoupling, maybe resilience. These all are advantages of event-driven architecture. Let me explain you now one by one. So let's discuss scalability. Since components are loosely coupled, the components are designed in such a way that they have no coupling or very less coupling, or coupling based on some events, right? Which is not directly creating any strong couples, right? That's why it gives the advantage to this system to scale as per their demands. As per the system has demand, you can always scale your system accordingly. Second point is decoupling. I think most you can understand easily. Third is resilience. Resilience is something which is related with the failure, right? So failures in one part of the system do not hamper the complete system, whole system, right? As long as event persistence mechanisms are in place, system is working perfectly fine. Even though one or two components will fail, does not impact others, right? That is how this system is designed. Next is every system have challenges, right? No system is without challenges. As I already mentioned several times, that whatever you will build today, it never be the perfect for future. Like there are scenarios you will get in the future where you will feel that this is not sufficient. So challenges in this event-driven architecture is data consistency, because the interaction is asynchronous way, right? So most of the time your system is providing eventual consistency, but not the direct consistency or strong consistency. All right. So that's why that is literally, it depends on your system requirement. If your system is okay with eventual consistency, then definitely this architecture could be a core concept in your design discussion. But if not, then you have to think about it, right? Because in this system, because of decoupling or because of uh, asynchronous behavior of the components, there is no guarantee that data consistencies. There is no guarantee for a strong data consistency, right? Another thing is because it's a loose coupled, sometimes latency is will occur into the your system, right? So I think that point is also explained to you. Third is it also increase the complexity, making the system decoupled is unknowingly bringing some kind of complexity to your system. As I already explained several times, that it is like give and take kind of relationship. If you are bringing design which is super flexible, uh, very decoupled, because you can scale and other things of that, but that brings the challenges into your system also. Now it requires and different kind of mechanism to handle in every place's source and destination, because there are chances that source will fail several reasons because of destination, right? And destination also vice versa. So similar way, I'm saying that it requires a specific kind of handling in every component due to these kind of decoupling handling, right? So at the end, let me conclude today's topic, because otherwise video will be very large. And if you have any concern or query, please put in comment. Ask me directly question by reaching to the direct message, and any other way, like whatever the mechanism you use, find suitable for your system, for your convenience. Please put it your requirement or comment, feedback, anything. Okay. So let me conclude this session now. So in the conclusion, I would like to say that event-driven architecture offers immense flexibility and scalability, but they also require careful consideration of the trade-offs, particularly around latency and data consistency. Otherwise, all these systems are, whatever you learn today is perfectly giving you a good set of design tools in your armor, and you always remember this thing. I'm also going to share you some source. Please go through those source and deep dive more detail, because this is just a view, I mean very high level view of the topic. There are definitely you need to go deep dive in each subtopics, in each sub area, and build the concept based on those subtopics. Because at the end, in that design discussion, it is you who can help your interviewer to understand your skills, your capability, your competence, right? So that's why, as much as you are aware of these things, you are able to convince your interviewer that you are very much designing the system by understanding it properly. All right. So by that saying, I'm just wrapping the video because it is getting large, and I hope that you enjoy this video, this kind of session. And if you have any comment, please provide into the feedback. Thank you. Bye. Take care.